Okay, for today, I will be going over the lesson of the extreme value theorem and extrema by doing two problems with them. The first problem that we have is this. F of x equals e to the power of x times cosine x on the closed interval of 0 to pi. The problem of this exam is to this function even has absolute extrema. And how do we do that? Through the use of the extreme value theorem. The extreme value theorem states that if f is continuous and differentiable on the interval 0 to pi, in this case, then the function has absolute extrema on this function x value through the domain of 0 to 2 pi, that the function is differentiable and continuous. So it has absolute extrema. So now we have to find what values of c within this interval will give us the absolute minimum and absolute maximum of the function. So let's erase this. First off, what do we do to find critical number points, which are numbers of c of the function that will give us the number within the interval numbers? The critical number is found by setting f prime of x equal to 0. And this is done because the slope of the tangent line the slope of the tangent line when 0 is the extrema of a graph. So let's find f prime of x. F prime of x equals, we do product rule. So we set the 0, and we can factor this because they both have factors of e to the x. So I want to pull out a -2 to make the equation on the inside cleaner. I get sine of x minus cosine of x. Now to solve for x. When solving for x, you can know that e to the negative x, or negative e to the power of x equal to 0. There would be no values of x of an exponent that would set u equal to 0. So this is a no. So we instantly know that this will give us no cn. Now for this, when you set it equal to 0, you get sine of x equals cosine of x. Okay, so what's x? How can we find sine of x when sine of x when it equals cosine of x? This requires some outside of the thinking box or remembrance to trig. As you might recall, that the sine of an angle and the cosine of an angle is similarly related to a special triangle known as a 45, 45, 90-degree triangle, where, here is the triangle, the opposite and the adjacent side of the triangles are equal. They're 1, 1, and the hypotenuse is square root of 2. So, and there's your x. So would you agree that sine of x equals rad 2 over 2 and cosine of x equals rad over 2? But that would give us one critical number value of, we have to be in radians, so it can't be 45 degrees, so it would be pi over 4. But there is one mistake that can be easily done within this problem. This is the main why I chose it, is that there is another value of critical number that we can get from the single equation, so we can get two critical numbers. I'm going to erase my work here to show more work. I'll keep the original equation. And that is, so far we have one critical number due to f prime of x. I'll rewrite it. We already have one critical number, which we just found out, which was x equals pi over 4, which equals 45 degrees, which thus gives us the when sine of x equals cosine of x. But there is another value that will give us sine of x equals cosine of x. And that is this right here, 5 pi over 4, or 225 degrees. As you can see, the values here are both negative, the opposite and adjacent, but the sine of x equals cosine of x still, but the sine of 5 pi over 4 does not equal the cosine of 5 pi over 4, thus making it its own critical number. So we get 5 pi over 4 as well. What makes us unique is that we can get two values of two critical numbers from one factorization, due to it being regarding trig. So now we have our critical numbers, pi over 4 and 5 pi over 4. Time to plug them in. So when we plug in our absolute extrema, we want to plug it into the original equation. So let's do it in an increasing order. It'll be the same thing as the equation above, except for the 5 pi. But remember that this is regards to the negative side of it. So this is going to be a negative number. So instead we get negative e 5 pi over 4 times square root of 2 over 2. Now for our final. Now, determining our absolute minimum and maximum. I'm going to erase this work, record these numbers as they will be important, and we're just going to make points, and then we'll determine the absolute max, minimums, and values. Now, determining the absolute max or minimum, you have to look at the lowest y value, f of x value, and the highest f of x value, or y value. Such as you would look at these to determine whether or not it is an absolute minimum or maximum. As you can see here, you would probably need a calculator to require certain exact values to know which one is which values of e are greater. But just from viewing it, there's only one negative number, meaning that this number right here is the absolute minimum. That's one down. E to the pi over 4 is less than 2 over pi. Then we're timesing it by square root of 2 and dividing it by 2. So e to the 2 pi would be greater value than e to the power of pi divided by 4 times square root of 2 over 2. So here we have our absolute max. The next problem that we'll be doing is regarding natural logs. Well, a very simple problem. So now we have to use, interval is negative 4 to 2. That's our closed interval. Now we have to use extreme value theorem to determine whether or not this function is continuous or differential on this closed interval. Is it? Well, the inside function of the ln natural log is a polynomial, so boom, that's our answer. The f is continuous and differential on this closed interval. We don't care what happens outside of the interval at all. That may be a problem that other people may have, but make sure you check what is the closed interval. So now, let's find our critical numbers. As you know, we have to find f prime of x, then set it equal to 0. What is the derivative of a natural log? Since in this case there is a function within the natural log, we do ln of u equals u prime over u. So let's do it. The derivative of x squared plus 4x plus 14 is simple. Now we set f of x equal to 0. For x, multiply right here, you get 2x plus 4 equals 0, x equals negative 2. That's our critical number of ours, and that's our only critical number. So now we test our three values within f of x. F of negative 4, f of negative 2, and f of 2 to find our absolute extrema. So let's do it in increasing order, just as we did in the last problem. Now, absolute max or minimum is the easiest. Just don't look at these right now. Focus on these ones right now, because the ln's will just bring the value of the numbers lower. So, which is our highest and lowest numbers? This is our highest, and that's our lowest number. And that's our absolute max and minimum. So, our absolute min would be negative 2 ln of 10, and our absolute maximum would be 2 ln of 28. And those are my two practice problems. I hope they helped you well, or if they didn't, that sucks. And just some tips. Look at the closed interval. Look at the closed interval that they're given you, and use the extreme value theorem. Because if you use this, you can make your life easier if a problem is asking you for the absolute extrema of equation within a closed interval, but it isn't continuous or differentiable, so You have your answer. There are no absolute extrema. It can be a quick and easy way to do this.